Okay, so today we move to the new chapter, which is the discrimination and classification. In your textbook, it is in chapter 11, page 575. So let us define what is discrimination and what is the classification. Okay, so actually we have two goals to do the discrimination and the classification, which is the first one is separate the distinct set of object, which is we define it as the discrimination. It is the data description, which is at this point we find the discriminants that best separate the groups. We find the discriminator that will have the best to separate the groups, to separate among group, to separate the observation or the objects to separate groups. Okay, we define what is the discriminators. Okay, kalau in your textbook ada dalam your page 575, dia punya ada explanation yang panjang lagi. If you can see, it's saying that in discrimination part, to describe the features of the object or observation from several known of population, we try to find the discriminant that the collection are separated as much as possible. Okay, we find the discriminant from the collection that are separate as much as possible. Okay, we find which variables that will function as the discriminators that have the best features to separate the observation into separate groups. Okay, that is the discrimination. Yang kedua, the second goal is to classify new object into well-defined population. It is known as the classification ataupun dipanggil data allocation, which is we put the new object in groups via the discriminants. We use the discriminators that we define in the discrimination tadi, okay, to put the new object. If we have the new object or we have the new observation, so we want to know this new observation will go to which groups or which population. Okay, ini yang dipanggil classification ataupun data allocation. So we have two goals here of doing the discrimination dan juga classification. Okay, we describe the features of the observation that will separate the groups, and we classify the new observation or the new object to go ataupun to be allocate to which groups ataupun which population using the discriminator. Okay, that is the introduction about the discrimination dan juga classification. Okay, so we can explain more in example through the example in example 11.1, page 578. Okay, alright. Consider two groups in a city, riding mower owners and those without the riding mower, that is non-owners. Okay, so we define these two population as owners and non-owners. So we have two population here ataupun two groups of owners and non-owners. In order to identify the best sales prospect for an intensive sales campaign, A riding mower manufacturer is interested in classifying families as prospective owner or non-owner on the basis of variable income dan juga lot size. Okay, random samples of 12 owner and 12 non-owner yield the values in table 11.1. Okay, we can see here from the informations given, we know that we have two population here, or we have two groups, owner and non-owner of the riding mowers, and then we have two variables, which is the income dan juga lot size. Okay, so dekat sini dalam chapter discrimination dan juga classification, dia punya population tu it denote as pi 1 and pi 2. Okay, alright, so we can explain the data here ataupun we can explain about the discrimination dan juga classification according to the figure 11.1, which is it's construct the scatter plot of x1 versus x2. Okay, because of we have two variable here, income versus lot size. Okay, and then plotted the point here in the scatter plot. We have two, whether it is riding mower owners or non-owners. Okay, the black dot is non-owner and the clear dot adalah owners. Okay, so what can we see from here? What can we observe from here? Okay, we can see that the riding mower owners tend to have larger income, okay, than non-owners. Okay, owners, which is the clear dot here, tend to have the larger income. Macam kita tengok dia punya larger income. If you can see here kan, this dia punya x1 ni, x1 axis. If you can see here, most of the ataupun more of the clear dot tend to be in the right side, which is larger income lah. Okay, and the bigger lots. Okay, kalau kita tengok x2, kita tengok x2 kat sini, kita tengok dekat sini, here is the black dot non-owner. Tapi yang atasnya lagi di sini adalah belong to the owners of the mower. So we can say that bigger lot. Okay, the owner have the bigger lot size of the square feet. Okay. But from here, from these two variable, we can see that income will be the better discriminator than the lot size, right? Because of, kalau kita tengok kat sini, daripada income ni kita boleh lagi yakin bahawa riding mower owner have the larger income than the non-owner of the mower. But there is some overlap between the two groups, which is here, this plot here. Okay, this point, these 2 point, actually it is belong to owner, but dia masuk ke dalam region R2. Okay, kat sini region R1, di sini region R2. Okay, we can say that region R1 ni adalah region belong to owner, and region R2 belong to the non-owner. So 2 point, these 2 point of owner, okay, observation from the owner falls in the region R2, and these 2 points, okay, that belong to the non-owner falls in R1 region. So di sini kita panggil ianya adalah incorrectly classified. Okay, some of the owners, these two, would be incorrectly classified as non-owners, and also the non-owners will be incorrectly classified as owners. Okay, so from here, apa yang kita boleh buat kat sini, we can do a good classification procedure. Okay, should result in a few misclassification. Okay, we want the probability of the misclassification should be small. Ini dipanggil optimal classification. So we will doing the optimal classification by a calculation. How to see the dia punya probability of misclassification, small or large. So yang kita nak adalah small misclassification. Okay, the next topic is the separation and classification for two populations. So in this topic, we can calculate the prior probability and the cause of misclassification, which is the optimal classification rule. Okay, and then from here also we can calculate the region of the population ataupun of the data. We have two region, so we need to know what is the region, and then when we have the new observation, this observation belong to which region, so we can calculate the region. But before that, you need to know what is the optimal classification rule that I mentioned before this. Okay, before this I mentioned that the cause of misclassification should be small, and also actually the prior probability should be large. Okay, so if one population is more prevalent than the other, chances are higher that a new unit ataupun new observation will came from the larger population because that population is more prevalent. Okay, dia punya, it have the greater likelihood of occurrence. Okay, because of that. So we need the stronger evidence to allocate the unit to the population with the smaller prior probability. Okay, so ini in terms kita akan tengok nanti bila in terms of we want to calculate the region nanti. Okay, yang kedua adalah cause of misclassification, which is, as I said before this, the cause of misclassification should be smaller as possible. So what is cause of misclassification? For example, it may be more costly to misclassify a seriously ill subject as healthy, which is, for example, the doctor do not treat the sick patient, okay, because it classified as healthy, than to misclassify a healthy subject as being ill, which is the doctor will treat the healthy person. Okay, or for another example, it may be more costly for a lender to misclassify a bad credit risk as a good credit risk and award a loan than to misclassify a good credit risk as a bad credit and deny a loan. Okay, so if this cause of misclassification is large, so it will be worse, right? So because of that, cause of the misclassification should be smaller as possible. So we need the smaller cause of misclassification. So using the optimal classification formula nanti, we will avoid this, ataupun we will use ataupun optimumkan the classification rule. Okay, so for example, the two population classification problems. Okay, this example is from your textbook, page 580. Okay, let X denote a random vector. Okay, dia ada beberapa variable, kan, x1 until xp, and f1x denote the probability density function for population 1, and f2x denote the PDF ataupun probability density function for population 2. Okay. So given a realization of X, we have several of variables. We want to assign this X ataupun observation belong to which region, which population ataupun which region. Okay, X pi 1 or pi 2. Okay, we want to find some classification rule to determine whether a realization of X study should be assigned to population 1 or population 2. Okay. So we can create the formula after this to see if we have the new observation. So that new observation will go to which region. Okay, so let me illustrate this example. Okay, let omega denote the sample space, which is all the possible value of X. Maksudnya semua sekali lah dekat sini, omega tu. And R1 will be a subset of the omega, which is R1 will be the first region dalam contoh ni, figure 11.2. The region R1 is here, and the region of R2, which is the omega minus dengan region of R1, will be the subset of omega, which we classify as population 2. Okay. Okay, so how we find the next one is what is the formula of the prior probability of occurrence. Okay, we should express it as a conditional probability. So kalau conditional probability of P21 means that the probability that X has been classified as pi 2, which is the in the region R2, while actually it is from first population, the first region. Ataupun P1 given 2 adalah probability that X has been classified as population 1, while actually it is from population 2. Also, our aim, we want this prior probability should be as small as possible. Maksudnya, bila probability that X has been classified as pi 2, while actually it is from pi 1, so it will tend to give the higher value of misclassification kejap lagi bila kita calculate. Okay, let's see here. Apa yang digambarkan dengan tadi kan, dia punya nilai conditional probability tadi. Let's say here, we have R1 region and we have R2 region. We have the PDF of X1. This is dia punya distribution untuk fx1. Di sini distribution untuk fx2. Okay, di sini R1 region 1 R1, Di sini region R2. We can calculate this. Sekejap lagi we can see. Okay, so dekat sini kan ada punya tail of distribution untuk F1X tadi tu. Okay, ini adalah P2 given 1, which is the observation, okay, comes from which is, okay, yang ni tadi kan, 2, 1. Okay, the probability that X has been classified as X2 as R2, but actually it comes from F1 kan. So actually daripada sini bila dibuat region, kita bahagikan region 1 dengan region 2, so dia termasuk dalam region 2, but actually it belong to R1 actually. And then here this part yang dilorotkan kat sini pula, ini adalah conditional probability of 1 given 2. Okay, this one tadi, which is probability that X has been classified as pi 1, okay, population 1, but actually it is from population 2, okay, daripada this distribution. Sorry. Okay, that is we illustrate the conditional probability tadi. So from here kita boleh tengok dia ada misclassification probability. So apa yang kita nak adalah maksudnya kat sini daripada conditional probability tadi, we can specify also the misclassification probability, but the exact value kita boleh gunakan formula. Okay, so ini adalah how to calculate the expected cost of misclassification. Okay, alright. Okay, the formula dalam your textbook, it is on page 581. So untuk cost of misclassification, the notation will be C1 given 2 and C2 given 1. Okay, will be the cost of misclassification on object into pi 1 or pi 2, first population or second population. So kalau C12 means that it is the cost of misclassifying an object into first population, but actually it is from the second population. C21 adalah cost of misclassifying the object into second population pi 2, but actually that object observation comes from the first population. So to calculate the expected cost of misclassification is the formula. We need the value of cost of misclassifying dan juga nilai tadi conditional probability dan juga prior probability. So we want the ECM as small as possible. Okay. So kalau kita tengok the cost of the misclassification can be defined by a cost matrix here, if you can see here. If the if the observation is classified as first population, okay, when it actually comes from the first population, So dia punya value of cost misclassification ataupun cost of classifying will be 0. Right here, classify as pi 2, but actually it comes from the pi 1. So kita akan ada value cost of misclassification. Okay, and so on, sama juga dengan yang lain. Okay, itu untuk ECM. This formula you need to memorize. But macam mana you nak kira the probability, a prior probability, dan juga the cost of misclassifying. Okay, untuk conditional probability kita boleh integrate tetap kalau kita ada function of fx, kan, boleh integrate. But in this case, for this subject, you will be given the value of cost of misclassification and also the conditional probability. Okay, let's see result 11.1 ni yang saya cakap tadi, how we define the region. Okay, the region. Okay, this is the formula. Region R1. The density ratio of fx, f1x and f2x will be more than okay, the cost of ratio of these two multiply the prior probability ratio. Okay, untuk R2, okay, the density ratio less than, okay, the cost ratio multiply the prior probability ratio. Right, so this is a formula to define the region. Region 1 more than or equal, region 2 will be less than. If we have all these value, cost of misclassification and also the prior probability, so we can define the region. Okay, but if we do not know the prior probability of first population and second population, so we can assume it's equal. So if the equal probability, equal prior probability, so this the formula to get the region will be like this. P1 equal to P2. Ni je. So dia tak adalah kan, sebab sama kan, akan jadi 1 kat sini. Kat sini dia akan jadi 1. Because of that, the formula will be like this. If the misclassification cost is equal, okay, the formula will be like this. Yang ni akan jadi sama. So di sini, this part will be 1. The cost ratio will be 1. But, and lastly, if the prior probability is equal and the misclassification is also equal, the formula of region to get the region will be this one saja. Untuk dapatkan region 1 will be more than 1. The region untuk R2 less than 1. So bila kita ada region ni, kita tahu kan region untuk region, the first region more than value dia apa, untuk second region less than value apa. So kita boleh tengok, we can check the new observation. Bila kita ada new observation, it will false in the first region or the second region. Contohnya, for example, page 583, example 11.2. Okay. A researcher has enough data available to estimate the density function fx1 and fx2 associated with the population of pi1 and pi2. Okay, suppose that the cost misclassification into second population when it is come from the first population is 5, and the cost of misclassification when into pi1 when actually it is pi 2 is 10. In addition, it is known that about 20% of all the object ataupun all the observation belong to pi 2. Okay, apa maksud this sentence? Maksudnya, okay, the P2 equal to 0.2. Okay, the P2 0.2 because dia kata 20% of all the observation belong to pi 2. So P adalah probability of prior, right? So P2 will be 0.2. So automatically P1 will be 0.8. So now we want to classify the region. You want to know region 1 macam mana, dekat mana, region 2 dekat mana. So we use the formula tadi. Okay, this classification region formula tadi. So because of we have the cause of misclassification, we have also the prior probability. So we can say that here you akan dapat region 1 bila density ratio is more than or equal to 0.5, then and the region 2 will be lies bila the density ratio will be less than 0.5. Okay, and then dia kata classify x0, which is the new observation ataupun new object, given that f1 x0 is 0.3 and f2 x0 is 0.4. So using the formula of this tadi, kena cari dulu the density ratio. It will be 0.3 divided 0.4, it is 0.75. So 0.75, the density ratio ni will lies in which region? So it will be, we can make conclusion because of the density ratio is more than 0.5. So the new observation ataupun the new subject tadi will classify belong to pi 1 ataupun the first region. Okay, belong to first population. Okay, it will falls in the first region, the R1, and it belong to the first population. Okay, that is how we doing the classification. Right?